Hi, I'm an old guy and I do maths, and today we're looking at what it means when we strike a determinant that equals zero. Now, what is the determinant? Well, when we go looking to create an inverse matrix, the first thing that we have to do is we have to calculate a thing called a determinant. And if we were to label the numbers in this square matrix A, B, C, D, the determinant would be A times D minus B times C. So that would be 2 times 9, which you can see there, minus 6 times 3, and that would give us 0. That is a zero determinant, and if we were then in the business of creating an inverse matrix, we get the following. So part of the process of inverting the matrix would be to swap the positions of those, make that negative, and we would have 1 over 0 here. Now, try that in your calculator. 1 over 0 is kind of a black hole. It's going to give you a syntax error or some such thing. What it means is that we can't continue this operation. What are the consequences of that? What does it tell us? Well, it tells us a number of things, and I've got them listed here, and I'd like to go through them. It tells us that there is no inverse for this matrix. That's the first thing. So there is no matrix of this to the power of -1. There is no inverse. What's a consequence of that? Well, if you're using this to solve simultaneous equations, there's no solution for the set of equations. Now, what does that mean? Well, let's have a look here. Just on the next page, I've got some numbers. And what I've done is I've taken the numbers from the matrix, so just to remind you, 2, 6, 3, 9. It's a little rough, I apologize for that. So 2, 6, 3, 9. And this is normally, if you had a pair of simultaneous equations, this is normally how you'd set out this matrix. What it means is that there is no solution for these two equations, as in they don't meet. Maybe the lines do that. They run parallel, but they do not meet. And we can confirm that if we take, let's have a look. What shall we do? We'll multiply this by 3 over 2, I think. So if we multiply that by 3 over 2, what we get is we get 3x plus 9y equals, divide that by 2, 15 multiplied by 3, you get 45. And what you can see is that we've got the same gradient, and it's very likely that these two lines, as I say, do something like that. Can we work out exactly what it is they do? Yes, we can. We can divide through by 3 in each case, and if we do that for this equation, we get x plus 3y equals 15. So 3y equals 15 minus x. So I'm wrong. The lines go like that. Negative gradient. Y is equal to 15 minus x over 3, which is 5 minus x on 3. Now, if we take this one let's see what we get. So just a reminder, this was y equals 5 minus x over 3. Negative x over 3 is the gradient. 5 is the y-intercept. Let's take this one and we'll just divide this by 3. So we get x plus 3y equals 18. Very, very similar result. Y is equal to 18 over 3, which is 6, minus x over 3. So y equals 6 minus x on 3. Yeah, these things run parallel to each other. Y-intercept of 6 here, y-intercept of 5 here, the same gradients. There is no solution. Okay, so I'm sorry that that's messy, but that's me working on the fly, as they say. Now, so definitely no solution. So no inverse, no solution for its set of equations. A possibility is as follows. An infinite number of solutions. Now, what does that mean? Well, here's a second set of equations, and in each of these I've made up the numbers on the end here, but I've kept the numbers in here the same, because looking at the matrix we don't know what these numbers were. Okay, so we do the same thing again, but we'll just hurry the process up a little bit. We'll divide this by 2, and we get x plus 3y equals 6. And divide this by 3, and we get x plus 3y equals 6. They're the same equation. What are they going to do? Well, I'm going to spoil the surprise. They're going to sit one on top of the other, like that. You're not going to be able to see one for the other. They are going to sit exactly like that. And an infinite number of solutions means that these two equations are the same all the way through their trajectory across the Cartesian plane. So that is a possibility, but it requires a certain set of numbers here. Whereas if you go back up the top here, whatever numbers you put in here, except perhaps for the two numbers that I've nominated down below, these two lines will be parallel to each other. So, long story short, what does it mean when the determinant is 0? It means that the matrix has no inverse. If you're using it to solve a set of equations, it means that there is no solution for that set of equations, or in very special circumstances there is an infinite number of solutions. I hope that was clear. There's a lot of numbers flying around there, but it's worth thinking about. And I get asked a lot, so what does this no solutions thing mean? Well, you've seen what it means. Thanks very much for watching. I hope you found that useful. If you did, please like and subscribe, and I'll see you next time. Bye.